So, let's get started. My name's Adrian Otto. You're all here to hear about Docker on multi-cloud. First, a little bit about me. You may have seen me earlier in the panel discussion in the DevOps track on Friday. I work for Rackspace. Most of the things that I do at Rackspace are not related to Rackspace's internal business. They're related to our pursuits in open source. I'm leading as the PTL of two projects in the OpenStack ecosystem. One is Magnum. That's a containers as a service project for OpenStack. And the other is Solem, which is a way to get from source code to running application on OpenStack. And I also have some background in cloud standards. So a lot of what I do is collaborating with communities. So when I say multi-cloud, obviously that's a term that's overloaded, so I'm going to define it. Today I am talking about cloud portability. I'm not talking about running your app simultaneously in more than one cloud, because people don't really do this. And there's a good reason why people don't do this. Number one reason is most applications today are stateful, and moving state between clouds is relatively slow and problematic. The other reason why is this gets very expensive. So if you are actually moving a lot of data in and out of your application, you do a lot of replication over the public links, you end up paying a whole lot. So if you're doing something that is stateless in nature, this makes perfect sense if what you're trying to do is performance or cost optimization. But if what you're trying to do is high availability, I would urge you to do it, pick a cloud, and do it within the regions or zones of that one cloud, rather than trying to do it across multiple clouds for these reasons. So if you want to write a new application that works on a variety of different clouds, you've got a bunch of options. Just about every popular language has a cloud library. You can write your infrastructure code against these libraries. So give me a machine to run would map equally well to Amazon or Rackspace or private cloud using any one of these tools. But not all of us have the luxury of writing a brand new application for the cloud. Sometimes we're trying to run applications that were not written with the cloud in mind. And that brings us to containerization. So containerization is one technique that you can use to bundle up your application, all of its dependencies, and make that portable, regardless if you're trying to run that application on a private cloud, on a public cloud, maybe on multiple public clouds. The overview of my talk is how to do that. I have a lot of questions when I give talks like this about, what if? I'm going to get to the what if slide in just a minute. What I'm going to talk about today is using a formula to produce Docker images. Use those Docker images as the portable artifact. You run Docker on your cloud servers. You have your data in whatever clouds you want to run your application in, and you handle that outside of the container. And when you're ready to run your application, you load it from the repo and restore your data from your backup or load it directly from your live replica. So if this doesn't sound interesting, y'all can get up and leave. You're all interested. That's great. Okay. But Docker is not a panacea. I think you've probably heard that 5 or 6 times, maybe more, during this conference, if not before. These are the questions that I usually get asked when I get to the QA section of something that I've glossed over and I say, Docker is great for this. And they say, yeah, but. So, yeah, but what is a Docker? We're probably past that by now with this team. So I'm not going to spend a whole lot of time on that. I'll kind of touch on it briefly. What is a Docker file? This is something that's misunderstood by anybody who hasn't been using Docker for a while. So I'm going to drill on this a little bit to make sure that it's clear what the difference is between a Docker container, a Docker image, and a Docker file is. What is an image repository, and how is it similar to a code repository? What to do if you have a ton of servers and services that span, so if you have a single service that spans a whole bunch of servers, how do you deal with that? rather than just something that fits nicely into a single container? What happens if you have a multi-tier application that has dependencies? How do you deal with those dependencies? And what do I do if I just have so much data it's too big to move? So we'll talk about each of these things. Docker doesn't solve most of these problems. But I will tell you about the stuff that it does solve. So let's cover the what is Docker one first. As I mentioned before, I want you to remember that there are three conceptual things that are combined to produce what I call a container. So that's the C groups. These are things that limit how, or they determine how much of the system your application can use. Things like CPU limiting, things like memory constraints. Okay, these are controlled by C groups. You can think of a C group as a arrangement of processes that are running on your Linux kernel. Can be arranged in a hierarchical fashion under a C group. So if you think of it that way, you'd be pretty close. Namespaces are about restricting the view or access of an application to a defined set. So every process that runs on a Linux system runs in a namespace. By default, it's the root namespace. You can clone that namespace. You can restrict what is in that namespace. So you can create new ones, and you can create processes in these new realities that are smaller than the total system. So I can say, all right, if I've got all these different network interfaces, I can create a network namespace that only contains one of those network interfaces and run my application inside of that, and the application only has the view of that single network interface. And that applies to all the different resources that are in the kernel. The third thing is an image. The image is all of the application code for running your app, all of the libraries it depends on, and a dependency on a parent hash that is linked to another image that it is descended from. So in programming speak, I would say you have a class and you create a subclass. Okay, and Docker image is a subclass of another image until you go all the way up to something special called a base image. So the base image is just the first one, and then you create other images that are cascaded off this. I'll talk about this a little bit more. But the Docker image is the thing that makes Docker special. I think it's the thing that makes Docker special. It's what allows that portability of the application. This idea of running an application in multiple clouds and having this instrument to move things around is possible because we can bundle everything up in the image. So all those three things together are the Docker container. So the next thing is, what's a Docker file? So I said just a minute ago that you think of this concept of a subclass, right? In this case, the superclass is CentOS, and the subclass is CentOS plus HTTPD and a shell script called start.sh. And it's by default got a network namespace that doesn't allow any communication with the outside, but has port 80 proxied in. That's what this says. Now, if you can think of the Docker file as a makefile, then you've got the right concept. Okay, a makefile is just something that says, I take these C source files and I make a executable output. A Docker file just takes a set of imperative instructions and produces a Docker file, or a Docker image as an output. See, I did it, I confused you. So Docker file, when run through Docker build, produces a Docker image. Once you've got an image, you put it in a thing called a repo. So I gave this talk twice before, once in October to the UUASC group in LA, and I gave it again in Paris at the OpenStack Summit. And at both times I asked, how many of you use Git every day in your job? Okay. Every single hand in the room went up except for one. Okay, well that was one less than last time. Maybe you're just tired. But if you understand how Git works, you understand how the Docker repo works. It's just instead of source code artifacts that go in there, they're image artifacts. So the semantics are all the same, right? Docker pull is take something out. Docker push is put something back. Docker commit is take the current running state so that I can save it and then push it back into the repo. So push, pull, all that stuff is all the same. It also has a concept of tagging. So you can have an image that you tag with an ID string. And the most common ID string is :latest, right? So you build the same image over and over again. :latest would point to the one that you did most recently. All right, so let's talk a little bit about if I've got a ton of cloud servers. Docker is not enough. Docker alone, what we call Docker today, is not enough to deal with a multitude of servers. If you're doing that, you also need another thing to help you schedule your work across the resources that are available in your array of Docker hosts. You have lots of choices here. If you're an OpenStack user, you can use Nova. It has a scheduler. It also has the ability to run a virt driver for Docker. If you don't need advanced features from it, you would use that. If you do need advanced features, you would use Magnum, so that you can get at the specific things like, how do I set environment variables when I'm running my container? How do I inject the running command? How do I create an overlay network between containers? Those sorts of things are not possible in Nova, and they are possible in Magnum. Now, if you're not an OpenStack geek, there's always Kubernetes. Everything I'm going to show you in the demo section of this talk, Kubernetes also has a way to do, an equivalent way to do. So the things I'm showing you today are what are in the Docker ecosystem that are equivalent to what are also available in Kubernetes. Kubernetes has been around a little longer, so it tends to work a little better now. But this stuff is up and coming, so you deserve to see what it does. Mesos is an Apache project that also acts as a scheduler. It's not as popular as Kubernetes. Swarm is a new one, which we'll be talking a bit about today. It's a Docker ecosystem project. And if you are using a lot of cloud servers, chances are you've already got some kind of configuration management system, and you already understand the difference between cattles and pets. But I'll touch on this again. All right, what if my application relies on some other thing being launched before the application starts? How do you deal with this situation? So if I say I want to run, well, let's see, this slide is not what I'm talking about. Okay, so this slide is about if I need to run a data server, do I write my data into the container file system itself? A lot of the questions that we heard earlier about, like, which of the storage plugins should I be using for Docker? Should I use the Btrfs one? Should I be using the DevMapper one? Should I be using, and there's a list of these things, and they all have their quirks. And Jerome, very astutely pointed out that they all have their advantages and disadvantages. My attitude is, it doesn't matter. My attitude is, the container itself is read-only. And any data that I'm going to write, I'm going to do to a bind mount, and I'm going to use prevailing storage techniques. So whether I decide to use Flocker, or whether I decide to use a NAS, or whether I decide to use Ceph as the block store to build my file systems on, I'm going to handle those at the host level. I'm not going to handle those at the container level, and I sidestep the entire issue. So I don't really care if the storage driver for my container is a little bit unstable, because I'm not going to be writing to the file system. So I would recommend, if you're doing something like running a MySQL container, that you do this, which is -v. This is a bind mount of the /data/myapp directory on the host to /myapp in the container. And it's going to expose port 3306. Start the MySQL container with the tag latest. All right, so if you want this to start up first, you need to use an orchestration tool. One such we already mentioned, Kubernetes can do this. It has a declarative definition of what your service should look like after it's done executing, or after it's done going through its bootstrap process. So it takes a declarative approach. There's also a way to do this using an imperative approach. OpenStack has an orchestration tool called Heat, and it does it in a declarative way. So this would be an example of that. This says, start a cloud server resource called server1. It's of type Nova server, and it depends on something else called database server, which is an OS Trove instance. So Trove is the database as a service resource in OpenStack. This says, first create me a Trove instance. Once that instance is available, wire it up and start the Nova server as a result. And there's more to this file that I won't get into. There's a way to actually get the port and the credentials and everything wired up in the Nova server. Let's talk a minute about if I have a lot of data, just don't put your data in the containers. This concept of data containers, I don't believe in data containers yet. I haven't been convinced. I still believe in putting data where I trust it today, in the file systems that I trust today. I don't yet trust the layering file systems to be my authoritative store of my data. So my advice at this stage of maturity in container image land is just not to use them for persistence for mission critical data. So if I'm going to get fired, if I lose this data, I don't store that in the container file system. I use bind mounts instead. So let's talk about Swarm. Now, the other two times that I gave this talk, the second half of this deck was different. All this used to be talking about libswarm, and now all of libswarm has been changed, and now this is something new. But the idea is still the same. The idea that you have a multitude of hosts that can run containers that are provided to you with a singular view. That's what Swarm is about. It's about providing you a virtual server, or the virtual API that has many servers behind it. So it uses the Docker API on the front, looks and behaves like a Docker host would behave, except the containers actually get started on more than one host. It has a built-in research scheduler. It has pluggable implementations for both filters and strategies. It has a constraint filter, which means if I have a tag on one of my hosts, I can say this container needs to run on a host that has that tag. So if I make a tag that says SSD storage, I can say run this container, and the constraint is tag SSD. It's only going to run on a host that has the same tag. That's what constraint is about. Affinity means run this container next to this other container. It has port, which means given this port, find a host that has this TCP port number open and start it there. I agree. And then it also has health, which is the idea for that one is just if you've got a host that you know is in trouble, not to schedule resources on it. There's two strategies. I'll get to you in just a sec. I have two strategies for distributing your containers across your nodes. One is bin pack, which means fill the first one, then fill the next one, then fill the next one. If this makes sense. And the other one is just spray my containers evenly over all the nodes. And the reason why you might want one or the other, random is going to give you the best distribution of your load across whatever infrastructure you own. And that makes sense if you're running this on maybe a private cloud deployment and you have an idea of exactly how many servers you can afford to allocate to this cluster. Whereas bin pack would make more sense if you are running this on a public cloud and you only want to pay for cloud servers when you need them. So you would use your scheduling algorithm to determine when you need another host. It works by running an agent on each Docker host. The agent makes contact back to a master instance. So there's a master state called Swarm Master. There's another thing called the Swarm Agent. The Swarm Agent gives information to the master about what resources are available on the host. That's how the scheduling works. Now, that all makes sense in the concept of a single cloud. But Swarmd is a little bit cooler than that because it has multiple cloud backends. So I can have a cluster of Docker machines running in cloud number 1, another cluster of Docker machines running in cloud number 2, and I can address them together so that when I do things like Docker PS, I can get a listing of all the containers that are in all clouds. So if there's a good reason why I'm using one cloud for one part of my application, like maybe I'm doing video transcoding in one cloud because it's like really cost effective to do it over there, and I'm doing application, or I'm doing my database hosting and application hosting in another cloud because they have whatever, better redundancy, but I still want to have a unified management experience. Swarm gives you a way to get the unified view. And there are drivers for a bunch of them. I'll talk about that in a minute. Anybody want me to talk about this subject? You all good? Okay. So you still need to use an orchestration system. I touched on Heat. Other popular ones are Ansible, Chef, Puppet, etc. I would still use one of these. We'll just gloss over this. I think this audience is pretty well covered. Immutable infrastructure. So the idea of immutable infrastructure, I talked about treating containers as read-only entities. That's part of this. But what's more important is that the thing that you build to test your application, the binary artifact that you create, that Docker image, ideally should be exactly the same image that you run in staging, that you do smoke testing on, that you do integration test on, and that you finally run in production on. And the reason for that is so that what you're running in dev does not have different library dependencies in production. And because of environmental drift, you don't end up with that class of problem. Now, it was pointed out that not all issues relating to, it worked in dev are solved by this. If you had something, relating to kernel quirks, if your kernel is different in dev and your kernel is different in prod, of course you're going to get different behavior. But assuming that your kernels are the same and that you are running the same build in both test and dev, just about all of that whole category of issue goes away. And that is huge because I can tell you most of my ops experience has been spent dealing with this issue. So I have a particular place in my heart for it works in dev but not in prod. And I love solutions that help me approach the stamping out of that problem. All right, now there are a couple of different ways that you can deploy Docker. The simplest way is just to run Docker on the OS. So that would look like this on the left, where you've got your hardware, you're running your Linux operating system on top of that, you're running Docker on top of that, and then you can create containers, which actually don't run on top of Docker. I shouldn't have stacked it like that. The containers actually do run on the host. But the idea here is that there's a potential illusion of security isolation between containers. And I want you to leave this room, thinking that that is actually an illusion. It is not a reality. Because the things that separate so let's talk about first the multi-tenant model. This is the best practice for if you've got hostile workloads that belong to different entities. Like if you're a public cloud provider, this really matters to you. You want there to be a real security isolation between a container that's running for one tenant and a container that's running for another tenant. And simply having something like the Linux kernel with an SE Linux policy is not enough to give a real security answer. Whereas we already trust, as misplaced as the trust may be, we already trust that if you put multiple VMs using a type 1 hypervisor underneath, that security isolation is adequate. So if we already believe that that's adequate, then this arrangement of Docker is secure for multi-tenant use. And I would encourage that if you're going to use Docker in a multi-tenant scenario, that this is the way that you deploy it. If you're in a single-tenant scenario and the workloads are not hostile, it's okay to run them in this first way. And in many cases, you're just consolidating workloads in a single enterprise. This makes a lot more sense. It's much more efficient to do the left way. But know which time to use each of these. The syscall interface is the barrier between two Docker containers or two containers of any type running on the same host. Syscall interface is huge. It's hundreds of calls. It's very hard to lock down. If you do know how to lock it down, you lock it down to the point where it's totally useless in a general purpose capacity. You cannot access the things in the kernel that you need to access for your application to run. And when you open it up to the point where it's useful again, it's not secure. Whereas if you're using hardware virtualization as the barrier between containers that belong to hostile workloads, you're doing it at a level where the abstracts, the things that you're working on, the hardware virtualization itself are much more simple than the syscall interface. Any parents out there? Have anyone asked you where babies come from yet? Oh, you're lucky. Yeah, you're lucky. And yeah, when my son asks me where do babies come from, I say, "Oh, do you mean where Docker hosts come from? Let me tell you, I've got tools for that." Yeah, Docker machine is where Docker hosts come from. So I showed you these photos. These are diagrams of stuff, right? And this one on the right looks like a nice fat hamburger with lots of stuff in it. It looks like a lot of fooling around, doesn't it? A lot of like commands and juicy like configuration. Well, what if there was something that would make that easier? So yeah, that's where. I think it's a great idea to do. If you understand your workload, absolutely have a policy that limits how they can interact. That is a best practice. However, if you are in the business of providing a self-service container service to your constituency and you want that to be generally useful for a wide range of applications, the policies that you need to have are very, very loose and are therefore of diminished value. So if you're in a situation where you do actually understand your workload very, very well and you can put policies around them, absolutely do that. But if you're in a situation where you just need to give a general computing environment to a set of developers who expect to be able to use it for a wide range of things, that's not going to be a great approach. Okay. All right. So yeah, one of your options is you can just do all that stuff by hand. There's absolutely. But I would rather use a tool for it. There's a new one called Docker Machine. Docker Machine is to some degree is a splinter of what Libswarm used to be. Used to have back-end drivers for all the different clouds. Now we have these back-end drivers that are part of Docker Machine. And this allows you to start up a cloud server in whatever kind of cloud or virtualization environment you have, whether that be VirtualBox running on your own box, whether it be a VMware environment, whether that be Rackspace, Amazon, Google, whatever cloud you want. There's a back-end driver for all this stuff. There's even one for Microsoft Windows, which I just learned about. It has caveats, obviously, but yeah. So you can create the cloud servers with these things. I'll show you how this works in a minute with a live demo. But basically, you just give this thing a command. You say, "Give me a Docker host." It goes ahead and creates the VM, installs Docker, configures it, sets up the key pair and everything, and gets it working. I also got a question earlier this week. Can I use Docker Machine to get stuff running on bare metal? And the answer is yes, comma, if. So if you are running for example, a cloud that can produce bare metal images, so if you have, if you're a Rackspace customer, we have something called On Metal. If you're an OpenStack user, you can use Ironic to produce bare metal hosts, and in which case you can use the OpenStack driver for Docker Machine to produce bare metal hosts that run the Docker daemon that you can then deploy your containers on. So the answer is yes. So this is how the thing works. Let's try doing it. So I've got 3 environment variables. I've got an environment variable called OS region name. This is the place in my cloud where I'm going to start my virtual machines, my guests. My username and my API key. So those are 3 things you need in order to use the OpenStack driver. Every driver is slightly different, but all of them are going to require some parameters. These 3 parameters don't need to be supplied on the command line. They can just be absorbed through the environment, so I'm setting those that way. So I'm going to say Docker machine create, use the Rackspace driver, and call the machine Adrian. This process, yeah, I can make that bigger. Let me All right, you can read that, I hope. Yeah, okay. Sorry about that. This says create a machine called Adrian on the Rackspace Cloud and install Docker on it. And the process takes about, assuming I'm actually on the network, I hope I am, takes about 1 minute and 10 seconds to do. It goes out to the Nova API. Well, first it's using the environment variables. It uses the Golang library to authenticate with Keystone. Once it gets Keystone authenticated against the Rackspace auth, it's giving me a catalog for where to find the Nova service. It goes to the Nova service, creates the Nova instance for me, brings it up, gets the IP for it, connects to that host, installs Docker, sets up the TLS configuration, both on it gives me the local side of the key pair and the remote side of the key pair, and does it all automatically for me, and saves it, and then gives me the ability, once it's done, no, that's a real demo. Well, wouldn't be a real demo if it didn't blow up. Did you already have an Adrian? Maybe. It shouldn't have taken that long to tell me that, though. It doesn't say why. Sorry. But anyway, at least I got to tell you what it does. We can come back later and see if this other one worked. But what it would do is it would print out installing Docker, setting up key pair, and then at that point I would get the ID. It's going to print out to the screen to interact with this run Docker machine env demo. And so what that does is actually echoes like what the TLS ID is, the TLS file, where the endpoint is, that sort of thing. And so when you run that, this part right here, this Docker machine env demo, it's setting up environment variables that change the way that Docker behaves so that it's pointed at the remote instance rather than the local instance. So in this demo, I'm running Docker locally on this Mac laptop. It's communicating with the Docker daemon that's on the cloud server. And so when I do Docker machine SSH, it's going to connect me to that host. When I do Docker run to run containers on that, it's going to execute them remotely. And the advantage of doing this is sometimes the network link between wherever your laptop is and the internet where the base images are is a cruddy network. And it might take a long time for those things. If you're doing a lot of stuff, like say I'm building something for 5 different distributions of Linux, that would be a lot of base images that I might want to pull down the first time. If I created that host remotely, they're going to just be going over the wire to the Rackspace data center or the wherever my cloud is, and running at a much higher speed than they would be coming all the way down to my laptop. Okay, well that one worked. Probably because I had one called Adrian already, but you see right here it says, to point your Docker client at it, run this in your shell. Okay, let's do that. If you want to see what that actually is, it says use TLS, there's my TLS directory, and do that remote thing. So if I say there are no containers running, so I can say, okay, let's run one. Which CentOS do we like? Want to run? So I have a feeling that it would not be downloading this fast if I were doing it over the Wi-Fi network, even though that command that you just saw, that Docker command, actually ran on this box. So I might also say, now this is interesting. Why, if I just created a CentOS box, does it say Ubuntu? Okay, well the reason for that is the host that I created when I used Docker machine created an Ubuntu host for me because that was the default image ID. So I got an Ubuntu kernel. But I got the runtime that belongs to CentOS. Now, okay, well, if I didn't want CentOS and I actually want a Debian, well, I can do that too. And when I go in there and I ask what kernel, you see that's the same exact kernel. But I got a Debian environment that fast just by using Docker Machine to run a remote Docker host for me. So I could say instead of running it interactively, let's just run something as a daemon sleep per day. All right, and you'll see I've been running that container for 4 seconds. I'm going to continue to create these things. So now if I run Docker Machine again, anyway, it's going to show me that I've got one machine and that it's the active node. As you create more, you can set the active machine so that you're pointed at a single one at a time. So if you're inspecting one of your machines, you can, instead of specifying the machine name, if I do something like Docker RM or Docker SSH, this is a better example. So if I say Docker SSH AJO, which is the name of the host that I just created, it's going to give me a shell on the machine called AJO. If I say Docker Machine ABC, it's going to give me, oh yeah, that was the problem, and that's why it took so long for this to frickin' run, because I've got a metadata about a host that's not actually there. But here's the one that we actually created. You see it's got a star indicating that it's active. It's running on the Rackspace driver. Again, there are drivers for all kinds of stuff, including VirtualBox and all kinds of things. So, and what swarm it belongs to.
I feel like the way that you're naming these hosts is a little bit like a pet metaphor.
It's a pet metaphor, yeah. I am so pet-like. I have a name. If it has a name, it's a pet, right?
Right.
Okay. Yes. Yes, absolutely. But when you're done with one of these things, you tell it you're done. That should have been Docker Machine. And it's going to, of course, when you do this, it's going to go back to the Nova API. It's going to say, okay, for this ID, go ahead and do a delete against that cloud instance and make it go away for me. And of course, when you destroy a host, all of the containers on that host also go away. So, you've seen the demo of Docker Machine. There is a video of this that lasts like 5.5 minutes at adrianotto.com. If you just want to show this experience to somebody else without watching my whole talk, you can show them that. It gives you an idea for how easy it is just to get the machine up and running. Now this one's going to be a lot harder to read because it has a lot more stuff in it. But this is how to create a swarm using Docker Machine. So Docker Machine has swarm support built into it. So I told you that a swarm, in order to work, had like 2 roles. It had a master role and it had an agent role, and the agent connected to the master. So what this says is, go ahead and create me a VirtualBox, VirtualBox machine, and run this thing called, run a container called swarm, using the swarm image, and run create inside of it. It outputs a UUID, which is known as the swarm discovery token. So you can use that token to create the master with. And once you've created, so it says create me another VirtualBox. So I'm creating, so if I created one machine there, I'm going to create another VM here, and then I say, okay, set the master, set my Docker daemon environment, my Docker client environment locally to talk to the swarm master. When I do that, the containers that I create, instead of going onto a specific host, get sprayed across all of the machines that are in the swarm. So in this case, I've got right here node 0 and node 1, and the master, all which I can create containers on. So I've got a swarm of 3 nodes. If I say create a machine, it's going to use the scheduling strategy by default is binpack. It's going to use the binpack strategy to allocate the machine, the container to the machine that I created. So the first one would probably go into like node 0. The next one would also go into node 0 until I've got node 0 filled up. It's going to start hitting another node, that sort of thing. Full? Filled. When there's so the agent itself tracks the resources that are available on the host. I've only used memory as the constraint, so I don't know if it does others. It probably does, but I know it does keep track of memory. So if I say create, if I've got say a 2 gig host, I've created a 2 gig virtual machine, and I say create a 900 megabyte container and create another 900 megabyte container, the next one I go to is not going to fit, so it would fit on the next. And you could use other constraints as well, I'm sure, but I have not yet personally used those.
Yeah, I missed the first part of your talk, but is a swarm like a cluster?
A swarm is a cluster of Docker hosts.
Okay.
Yeah. Yeah. Okay, so if you do want these slides, this is where to get them. I will also be providing them to scale, so they'll be on the scale site as well for download. Questions? Or if you'd like, have both Kubernetes and Docker laptop stickers. So if you'd like to have those, if I didn't already give you one, you can come on up and get those. Questions?
When you use Swarm to create multiple clouds, does the master agent sort of relationship?
You have one master per cloud in that case. And the client can talk to multiple masters. Yes?
Swarm does constraints, and one of them was affinity, correct?
Yes.
Does it do anti-affinity?
Okay, so the question is, there's an affinity scheduler. Is there also an anti-affinity scheduler? I know the answer for OpenStack. I don't know the answer for Swarm. I know that it definitely does affinity. I don't think affinity scheduler does anti-affinity, but that implementation is trivial. It's just the ORD logic for OpenStack does both. Yeah.
Can you run the Docker image on the master of the Swarm, or does it have to be a separate?
Can you run the Docker image on the master?
So the master has to be just the.
So a master is just a container that runs on a host that you created. There's nothing special about the host that the master runs on. It's just a container that runs on that host.
So it's scheduled to itself.
Yes, it can schedule to itself if it is also running an agent. If you don't have an agent running, the master won't schedule to itself. So by default, if you're using Docker machine to create Swarm in this way that I showed you here, then yes, the master gets, because it also runs, the master also runs an agent, so things do get scheduled to the master in this case. If you didn't want that, you would just not run an agent there. Does that answer that question? Okay, yeah. So the services that involve Swarm are all containerized. So they're not actually running in the host, they're running on a container on host. Is there anything stateful about the master? Yes. And there be dragons. Because there is state, and because there's also distributed state, there are 2 copies of state. So if you create something through the Swarm, and then you go in and delete it directly, then it does not have convergence, and you will end up with a drift between what the master thinks is deployed and what is actually there. So be careful. If you're using Swarm, you just use Swarm. If you're doing things directly, that's fine, but you just need to understand that if you start taking stuff away, that you should be doing that the way that you created it.
Does that explain the Adrian?
Yes, that's exactly what happened. So the Docker machine has a directory called .docker/machine or something, and inside that directory, it's got the information about the host that you create. So the client side has a representation of what it's done, and so I went to create one that was already there, and it goofed. I wish the error message were better. I should probably submit a pull request for that. Yes.
Does the Docker machine allow you to get information from the container or the CPU memory usage and stat information?
It does have an info command. Where'd it go? I deleted it, so it's not going to give me anything. It's trying to talk to the one that doesn't exist right now. But it does give you, like, if you create a swarm and you say Docker info, you do get a little bit of information. You get, like, how many nodes are in this cluster, how many containers are on each node, broken down by node. You do get that level of information. But if you want, like, utilization information to inform a scheduler, then you would need something like a cAdvisor or Docker Stats, which you can stream now. The newest version of Docker has Docker Stats built in. You can stream that off the Stats API, and you could use that to feed into, another filter type scheduler, or you could use it to inform the strategy itself if you wanted. But yeah, that's not built in. All right. Thank you, everybody.